post your test and project grade. So those are in there. I know. Always proud of you. All right, number 7. Correct. Yes. Yes, I will. At the end of class, I'll hand you the test back, let you look. All right, guys, there are lots of phones out. I have a better view from where I am now. And because I'm starting to get some complaints, I'm starting to get some parent emails and parent calls. And I told you until that happened, I would not crack down on you. But since that is starting to happen, put it away. Yeah. Yeah, the end of class. Your phones. What? You don't know what you made yet? Yeah. All right. Write 2 monomials with a product of. Oh, and the computers unless you're on Canvas. I mean, unless you're on Miro board. Can't be watching film. What 2 things can I multiply together? Everybody's will be a little bit different for this particular question, but what 2 things can I multiply together to give me negative 84a to the 6b to the 10th? Does anyone disagree with Wyatt's answer, or do we all agree? Oh, you did b to the 5th on both of them? I'm sorry. Okay, you put 21. 21 what? Agree or disagree? Agree, I agree. You see what I'm saying? Everybody could have something different. Does that make sense? Sullivan, what'd you put?
I did that too.
You did what? You just told me your answer.
Yeah, but I didn't put an answer. I was making up on the fly. I didn't know how to do it.
Who? Sullivan? Was it? Oh. Like that was very condescending. That's the 101.5. Do what? Out of 50.
Yeah, that's terrible. Everything has 80.
Yes. It wasn't on the test. It was on the project. If you had like a lot of equations or, I'll give it back to you so you can see. And if you want your actual project, I have the rubric that you can keep. If you want the actual project, you can take it. Otherwise, I'm going to hang it up. No, yours is not going up. Sorry. All right. Number 8. The side length of a cube can be represented by the expression 2x to the 5th. If the side length is doubled, write an expression to represent the new volume of the cube. So the first thing I want to know, so this is the side length. How do you find volume of a cube? But it's a cube, which means what? Think back to geometry. They're all the same. The length, the width, the height, everything's the same. So it's really just each side multiplied together, right? Side times side times side, or length times width times height, but they're all the same. So if this is the side length, but it says what happens? It doubles. So I take this and double it. So now my side length is what? What's 2x to the 5th doubled? 4x to the 5th. Why didn't you do anything with the exponent? That's right. If I just times it by 2, I'm only worried about that coefficient in front. Well, now I can do the volume. So now the volume of the cube is going to be 4x to the 5th times 4x to the 5th times 4x to the 5th. And what does that give me? Okay, so simplify it even further. 64x craziness. Insanity. Test, yes, quiz, no. No. I have a question. What else? Okay. So glad you asked about that. Number 9 says to write it in standard form, then classify the polynomial. And there are two ways that I classify. Sullivan, did you share what went off the board with everyone about the classification? So standard form means I write it from the biggest exponent down. So 4m squared minus, or cubed, sorry, 9m squared minus m plus 25. And then I'm going to look at two different things. I'm going to look at the degree and the number of terms. And that's how I'm going to classify. So classified by the number of terms, how many are there? There's 4, and 4 means what? Polynomial. It's a polynomial. I also know that the degree, somebody already said it, is 3, and that's cubic. So I'm going to call this a cubic polynomial. That's your classification. So just as a refresher, let's think about the degree for a second. If degree is 0, what is it? Constant. How about 1? Linear. Quadratic. Cubic. Quartic. Quintic. Okay, those two are wrong. Yeah. Linear. Constant. Linear. Quadratic. Cubic. Quartic. Quintic. Then we just call it an nth degree polynomial, 6th degree polynomial. Yes, if it's not. Well, it depends on the number of terms. There's two types of classifications. This is the degree. And then you have the number of terms. Okay. 1 term is a monomial. 2 terms is what? A binomial. How about 3? How about 4 or more? You put these together. Yeah, so cubic binomial or linear polynomial, which you wouldn't have a linear polynomial, but a quintic polynomial or constant 0. Terms, polynomial. This is 4 plus. I can, yes. Look at number 14. No, bad one. Look at number, classify that polynomial. Cubic trinomial. Does that make sense? Don't worry about the ones with more than one variable. Did you say 14? 2a squared b minus 5b. What? Open that bottom right drawer of my desk, and I think there's some there. So this we have to go back to that definition we had of a like term. What does it mean to be a like term? What's the same? Same base, same exponent. Y'all look so collegiate like this.
I know.
So collegiate. So same base, same exponent. So let's look. I'm going to start with that one. Do I have any others that have the same base with exponents? So A to B. Yep. What is 2 minus 7? Negative 5. I keep. Oh, it is. You're right. You're right. I didn't look at the operation. I'm sorry. I got so excited that y'all knew how to do that. 9A to B. And then negative 5B cubed. Do I have any more B cubes? I do. So that would be minus 12B cubed. And then 4A4B2. 8A4. So negative 4A4B. If it was in standard form, yeah. Well, we won't do a lot with double variables like that. Standard form, yes, if it was. Yeah. It was subtracting, so I changed it to addition and changed all the signs inside the parentheses. Yeah. You don't have to. If you can look at it and tell, as long as you can come back to the right thing. You didn't subtract. You could. That's why I don't like the double variable ones. That doesn't. So don't worry about standard form with double variables. No, you do, but as far as standard form goes, not for standard form. Gosh, y'all are whiny today. Look at number 19. Negative 42 x10 y5 plus 12 x8 y3 minus 6x squared y over. Did I show you the same exact one? Oh. Okay. No, he said it wrong, but I knew what he was talking about. You said 7x8 or 7, 8x, I don't know. So this just splits up into 3 different fractions here is all that does. 21? Oh, sorry. Go ahead, Ellen. What? No. You got what? It should be 6. Yeah. 20? 16a to the 4th minus 40a squared plus 24a over 12a cubed. Same thing. So make it into 3 different fractions. Every time there's a plus or a minus up top, you can split it over everything in the bottom. Now I just simplify each one individually. 16 over 12, both of those can be divided by 4. Leaves me with 4/3. And then I have 4 a's up top and 3 in the bottom, leaves me with 1 up top. Both of them divided by 4. What? Who, me? What are y'all talking about right now? This is all I wanted y'all to do, was split up the fractions. There's not a lesson on division. Y'all, yes, because I actually did this problem with y'all. Yes, I did. To be. What is B? The base? Okay, so the base, this tells me here, length, which is the base of a, oh, because, yeah, that was a rectangle, is x plus 3. The width, so this is the base. The width is x plus 7. The height is x minus 1. So I'm going to do 2 times for surface area. I'm going to do, the point of this problem was being able to manipulate the polynomial. 2 times x plus 3 plus perimeter. Sarah, can you put that away, please? Thank you. Plus the perimeter, which the perimeter of the whole thing is going to be all the way around, right? So I'm going to add all 3 of these together for perimeter. Actually, I'm going to add length, length, width, width. Not like this, no. No. Times the height. Listen, I don't care that you don't know the area, the surface area of a prism. Obviously, I don't know the surface area of a prism. That's not the point here. The point is, if you're given something like that, can you simplify it? What? I'm listening.
Put those 3 equations together, and that's your equation. How do you get that?
Wait. Wait. The point of this problem is not the prism itself, but this part. All right, guys, I need all laptops shut because everybody's talking about they don't understand and this, that, and the other, but part of the problem in here is the distractions going on. You can't possibly understand math if you don't pay attention. Yeah. Two times the base plus this is the perimeter of the face plus the height. If you don't understand how I came up with that, it's okay. I want you to be able to work this and simplify it. Yeah. Huh? No, I don't want you on the notes. If you can't see from where you're sitting, move up. All right. Anything else? Yeah. No. I'll just say simplify this and put it in standard form. And what that looks like based on their degree and based on their degree and their number of terms, right? So now we're going to talk about some things that happen with the parent functions. We've talked about 3 of these already. We're going to add one more to our list of parent functions here. Golly, keep accidentally exiting out of that. Come on. I didn't. Oh, you talking about the picture? Because it was too busy. I couldn't see the icons. I have to have something dark so I can see them. You know how I am, Dozier. I have to be able to see the icons and read the words with it. I'm sorry. All right. So the parent functions you already know. Constant. What does the graph of a constant look like? Straight. It's just straight. Horizontally straight, right? How about linear? What's it look like? What's the parent graph look like? Somebody said diagonal. You're exactly right. 0, 0, 1, 1, -1, -1, and it's just a straight line through. How about quadratic? Notice I'm going up 1 on the degree every time I give you a new parent function. What does that parent function look like? Okay, I'm not going to call it a U. I'm going to call it a parabola. No, Dozier. I'm not including absolute value in these parent functions because absolute value is not a polynomial because of that absolute value around the x. What's the next one up? Cubic, because I'm going up 1. Thank you by the degree there. Does anyone know what a cubic looks like? It is. So I still have the same points. This is y equals x to the 3rd. I still have the same points here, but it kind of does this. As I start stretching and shrinking this way, that way, it can start to look more like this and have some actual humps in there. Sunny and Hunter, if y'all can put the phones away, please. Yeah, there's always graphing. Sunny, if you can put the phone away, please. Because grades are starting to drop and I'm starting to get parental concern. And the first question your parents will ask is, well, if the phone is distracting them, why aren't you telling them to put it away? No, it's not. It wasn't. I'm just saying. When it starts to get an issue. What is going on with this board today? I'm not going to get so specific with the points as we go a little bit further because we're going to use our calculators to do a lot of this. But a quartic, which is the 4th power, starts to look something like this. Notice what's happening as I go up a degree. 1 hump, 2 humps. It's like a W, and these can start, remember we're shrinking, they'll start to look slightly different from various transformations that we do, but in general, and it could open down, it could open up. What do you think x to the 5th or a quintic might look like? It adds 1 more. Each time I'm adding 1 more. Quintic. Now I want you to notice something, and I'm going to zoom out here so you can see these all at the same time. We're going to talk about in behavior. Okay? And in behavior is exactly what it sounds like. It tells you what the ends of the graphs are doing. And I want you to notice something. Y equals Z. As I move from one to the next progressively, okay? So here, my ends are going in opposite directions. Do you agree? Okay, 100, I really don't want to have to take that. If somebody can tell me I don't want to have to start taking stuff on, but if that's what I have to do. You can put that away, please. I would appreciate it. Y'all are so into the you cannot even hear me call your name. All right, the ends are going in opposite directions. Do you see that? Then what happens when I add another onto my degree? They're going in the same direction. Then what happens when I add another? Then another. Okay, keep that in mind. What happens, and let's take a quadratic, for instance, because it's the easiest one to visualize. If my leading coefficient, which is my A in front, is positive, those ends are going to do what? Go up. What happens if it's negative, though?
Going down.
They go down. So for that reason, and since you see as I start making my way up by degrees, things change, we're going to talk about in behavior in general. The opposites, that's exactly right. This one, if it was negative x cubed, it would do this instead of that. It flips it upside down. Remember those transformations? If you throw a negative in front, it just flips it upside down. Okay. It wasn't God. Yes, it is. It just is. This is not man-made. No. Okay. Listen, math can be found in everything.
I've never seen something that has a graph on it. When I use a man-made. Find me a real word application.
Don't tempt me. I'll have another project on Monday. He does. That's why he just swear mine all this. Okay. In behavior. We're going to classify polynomials in behavior. Y'all are real jerks, I tell you what. By their leading coefficient and their degree. This is a chart. I would write this big somewhere in your notes because you will reference this for a long time until you memorize it. Yep. Leading coefficient and degree. My goodness. Okay. Yeah. That's time to go, Roger. All right, I need to teach you the notation. Okay, I'm going to show you the notation we use to describe the in behavior. Okay, this is the hardest part to get about it. All right, so I'm going to come off to the side. Don't write this in your chart just yet. I'm going to say as X, and I'm going to use this little arrow. That little arrow means approaches. Yes. So all right. So as X approaches, and then I'm going to put, do you know what that means? Infinity. Infinity is really, really big. Do you agree? It's really big. So if I'm talking about where X is getting really, really big, which direction on the graph am I looking? X. Right. Hold on, I'm on a graph like this, and if I say, look where x is really, really big, I'm talking about over here. So this means the right side, the right end of the graph. As x approaches infinity, we're going to do both. It's got two parts. F of x, which is the same thing as y, approaches, and then I'm going to tell what it does. Okay? If the graph goes up, it's going to be positive infinity. If the graph goes down, it's negative infinity. Okay? For every graph, there are two ends, right? Say, think about a quadratic. Both of them up, both of them down. Linear odds, they're going opposite directions. So it could go both ways. If this is my graph, then as x approaches infinity, f of x approaches what? Is the right side of the graph going up or down? So I need to say that. So I need to say this is one side. My other side is as x approaches negative infinity, f of x approaches what? Negative infinity. This says the right side goes up, the left side goes down. This will be for every one of your polynomial end behaviors. The only thing you are filling out is this. It won't. Not for polynomials. They go on forever. Now, when we get to some other functions, no, because it could do that, it could do that, it could do this, it could do that. There are four possibilities. Four possibilities, right? Both ends could go the same direction, both up, both down. The ends could go opposite directions like this or like this. Those are my four scenarios. No, both up, both down, that's two. This way is three, and this way is four. That's correct. Yes. It is easy. Okay. The hard part is if I don't have a picture of the graph and I only have an equation and I'm asked what's the end behavior of the graph. Okay. So maybe I have right? That's a polynomial. You don't know yet. That's why I'm fixing to tell you. All right. You're right. Both ends would go down. That's just that one. I'm fixing to show you a general. Y'all stay with me. I'm fixing to pull this all together. That one I had on the side. All right. Look, I'm gonna use the leading coefficient and degree to be able to tell what means and so. A lot of you have already recognized the fact that all even degree polynomials do the same thing. In other words, a quadratic and a quartic, right? Because we looked at those. If I kept going, remember I told you opposite, same, opposite, same, opposite. If I kept going, every even degreed one would go the same direction, right? Yeah. So let's start putting even up top. If the leading, it should go under degree, sorry. If the degree is even, depending on which way the ends go, is if that very first number is positive or negative. That's what makes the difference. So, thank you. My exercise for today. What? Nope. This works for any polynomial in the whole world. So that says if you look at your equation and the leading coefficient is positive and the degree is even, then the end behavior, remember it's always going to start as x approaches infinity. What does f of x do? And as x approaches, these are going to be the same every single time. So what are the ends doing here? What go in the blanks here? If I'm a positive even degree, both ends do what? Oh, both of them go to positive infinity. So both of these would be positive infinity. And in fact, any even degree polynomial with a positive leading coefficient you could think of, 25 times x to the 424 plus 6x, I don't know. Both ends go off on that one because somebody was going to say something. I've been doing this job long enough. Stay with me. All right, on the flip side of that, instead of going up, if they're even but negative, I'm flipping down, right? So now, instead of as x approaches infinity, f of x approaches what? Negative infinity. And as x approaches negative infinity, f of x approaches negative infinity. Both ends go down. It's even degreed. All even degreed ends go the same direction. I hope so. Thanks, Will. Appreciate that. All right, if the leading coefficient then, I'm still talking about positive as opposed to negative, but my degree is odd. Oh, yes. What? You can do, there are 4 possible scenarios. I'm just making every possible. It doesn't matter. Whatever. Okay. Positive and odd. What? No. It's a chart. Y'all are killing me. All right. Let me just give you this one. As x approaches infinity. A good example of this would be just a linear function with a positive slope. So as x approaches infinity, the graph goes up, and on the left side, yep. That means on the right side, the graph's going up, on the left side, the graph's going down. Odds are opposite. This says the right end of the graph points up. The left end of the graph here points down. I'm aware. I remembered. Let me give you an example. Keep your chart as a reference. You will want to have this, okay? There may come a time whenever I say, okay, take out your chart and tell me what the end behavior is here. If you don't have it, you are SOL. Straight out of luck is what that means. All right, so look, anytime you see x approaches positive, thing, you can. So like this is right, up, left, up. This is right, down. I think when you see what you're going to have to do with this, it's going to, yep. How about the bottom one? What's it? Bless you. How about here? Right, up, left, down. Right, down, left. So two ways you're going to have to use this. Way number one, given a graph, tell without its equation, you'll give its in behavior. Visually look at it, tell me what it's doing. That's what we did. Way number two, given an equation, which is the more usually what we'll do with in behavior. Given an equation, tell me the in behavior. So for example, I'll just stay right there. Describe the in behavior. Which square are you in? The top right. Why? I would just copy this. And that tells me both ends are going down. I don't know what else is going on. Well, I do because I've done quadratics. Regardless of what else is going on in the middle here, both ends are going down. So both of them go negative. How about this one? Negative odd. So if you can think of a negative odd, that's an easy one to do, like a slope, a negative sloped line. So as x approaches, you guys, that's your homework sheet that I gave you. As x approaches infinity, f of x approaches. So which one? I'm negative odd, so I'm bottom right. So I'm positive negative, and I'm negative positive. Leading coefficient, degree. Degree is odd, leading coefficient is negative. All right, I'm going to stop right there for today because I don't want to